Hello students. Today we are doing 2020 electronics essay question. Right. Let's see what's the composition of the question here. Right. In the first part, of course, you can see write down the golden rules applicable to ideal operational amplifier. So in the first part of the question, part A, part B, and of course part C, you can see operation amplifier question where we have an LDR there. And then later on, the last part of the question, we have a flip-flop. Right. So that's the composition of the question. It's a good question to pick, right? So the students actually who picked 2020, it was a good question. I hope they have done really well in this question. Right. At the beginning of the very first question, they are asking a bit of a theoretical question. Write down the golden rule for it. So in most cases, actually later on, I heard from my students, actually they haven't written the first part of the question because they are not familiar with the golden rule concept. Sometimes we write down the rules, but we don't memorize them as golden rules on anything like that. Specialized names, actually we do not remember sometimes. That's the students, that's the benefit of studying the theoretical parts rather than doing questions. Actually you have to do questions for sure, but sometimes small theory parts, it will come in handy if you remember those stuff. Right, let's get into the question now. Right, in the first part of the question, the very first question, we have to write down the golden rules. So they are asking about the golden rules of an operational amplifier which is negative feedback. So actually now syllabus students, we have only negative feedback operation amplifier closed loop questions. So if it's closed loop, remember these things, there's a feedback, there's a connection between output and input in closed loop. That's how you recognize its closed loop configuration. Students, the first golden rule is this. First golden rule we have to write down, it's like this. There's the input, there's no current. If you can write it like this, actually there's no current flow towards, or there's no current flow into the operational amplifier, that will be enough. Or you can write the input resistance is infinite and all that, that is also correct. And the second one, of course, what you can write is that, of course, you should remember, because when you do the question you should remember that there's no potential difference between the input terminals. If you have written that, that's it. Those are the things you should know, right, when you do the question. So just write it. Right. I remember actually after the exam, some of my students actually they told me that they didn't know that this is golden rule. Actually, sometimes if you do not check your theories properly, you do not remember these specific words. Remember that. So when a situation like that comes up, students, the thing is that you cannot, suddenly you cannot make up something, right? So you have to write something. So the best thing is that you write something that you know, right? If they are asking for a certain rule of operation amplifier, just write down the rules that you know already, right? Maybe the words are not familiar with you, that the questions they are asking, but you should not make up something and write it. You would rather write something you already know, right? Remember that, right? Okay. So we are moving into the next part. Right, we had the B1 question. Let's read the question. Write down an expression for V positive here using V2, R1 and R2, right? Students, now we have made an assumption that there's no current flow towards inside the operational amplifier. So using that assumption, this current I flows this way and it goes that way. That's the assumption we make for now. So they're asking V plus potential. What's this value? V plus value, right? So potential here is V2, potential here is 0. So these two resistors, I can take it as in series. So I'm going to apply the potential divider method. So resistance ratio R1 is to R2 ratio is equal to the potential difference across these resistors. Say if you can find the potential difference across R2, that means that's the potential here, right? So R2 divided by R1 plus R2. So when you are doing an essay type question, actually when you are applying ratio method or potential divider method, you have to write the fraction like this, right? Then we multiply it by V2. So with that, I'll be getting the potential at this point. Potential across R2, since it's 0 here, potential at this point, it has to be this value. This is our answer in the first part, right? Let's move into the second part. Write down an expression for V negative here using V2, R1 and R2, right? Yeah, here see, for a moment actually I thought, is it wrong? Right, using V2, right? Yeah, see, they're asking to write down for V minus here by using R1 and R2 and V2 as well. So from our golden rule assumption, students, we know that there's no potential difference between input terminal. So if the potential here is say 2 volt, the potential here as well 2. So it's the very same value. So for the second answer, you can write down the very same thing, right? In the third part of the question, right, they're asking us to find V out using V1 and V2, right? So if you have previously proved this question, like closed loop questions, if you have proved it previously, and now you know the method quite similar to the previous method you usually do. So I'm going to use this current method. Say the feedback current flows from V out in this way, it goes in this way like this. So up to here, we get the very same current. So the previous assumption we made, right? This I must be equal to, say now, potential difference here V naught minus potential at this point V minus, that divided by R2. That's the current here. The very same current will flow towards this direction. Here the highest potential we have from this one now. So V minus minus V1 over R1. Right. Now we have certain kind of a connection, V out and V1 and V2. Obviously, actually we don't have V2 here yet. So we have to replace V minus value by using the previous value we found earlier. Right. Bit of a simplification actually we have to do. Right. This is the equation we got now so far. Right. Now we need to simplify and we need to subject V naught. That's what they're asking from us. So what I'm gonna do is I'm gonna subject the value of V naught. So I'll write it like this. V naught here, I hope you can see it. V naught over R2 minus V minus over R2 equals V minus over R1 minus V1 over R1. Students, we have to go further to a certain level with this calculation. So previously, if you have practiced these type of questions, of course, you are familiar with it. So without any uncomfortable feelings, you can do it with a confidence actually. So if you have tried previously questions like this, now you are comfortable with doing this calculation, right? Then my plan is I need to subject V naught here. So what I'm going to do is I'm going to send this part towards this direction. So now I'm getting V naught over R2 equals V minus over R1 minus V1 over R1 plus V minus over R2, right? So then I'm going to simplify it. V naught over R2 equals, I'm going to take these two closer. So V minus is common, I hope you can see it. So I'm going to take it out. Within the bracket, I'll be getting 1 over R1 plus 1 over R2 minus V1 over, I just let it be there. I'm going to simplify this one, right? So V minus actually from the previous questions, I know V minus and V plus both are equal. So I'm going to take it from the previous question. So V minus, previously we have taken it as, it's R2 over R1 plus R2 into V2, right? That's right. So in the bracket actually, so I'm going to simplify this. So take the common denominator R1, R2 and up we are getting R1 plus R2. And then here V1 no R1, right? Here in this calculation, see, I can see this one cancel off, these two. This one and this one cancel off, right? And R2 and R2 cancel off. Right, I'll be getting V2 over R1, right? Yeah, V2 over R1 minus V1 over R1, right? Getting closer to the answer. So here V0 equals R2. So I'm going to take this R1 cross multiplication. So it goes all the way R2 here. I hope you can see R1 that's common, so I can take it out. So now I'm getting R2 over R1, the brackets V2 minus V1. That's equal to V0. That's the answer for the third part, right? Moving into fourth part of the question. Here, they are telling us actually to make a small change, right? Yes, deduce an expression for V0 if R1, R2 are equal to R, right? So let's write down the previous equation we got previously. V0, I'll use some other color. V0 equals, we got R2 over R1 equals V2 minus V1, right? V2 minus V1, right? Yeah. So if all R are equal, these two are equal, so basically we are getting V0 equals V2 minus V1, right? That's it, right? Right, students, now we are moving into the fourth part of the question. Right, here the above circuit, let's read the question now. The above circuit in the figure 1 can be modified. Yes, modify to activate a burglar alarm. The modified circuit is shown in figure 2 here, this one. The right arm of the bridge circuit has two equal resistors of resistance R1 and the left consists of 50 ohms, this one. And a light dependent resistor LDR which is sensitive to infrared IR light. A narrow beam of IR light is allowed to fall to the LDR continuously. Here, when a burglar B, where's B? Here, burglar B, okay, burglar B enters the building, he blocks the IR beam. So when he actually crosses over here, the IR that falls on LDR will be blocked. So there will be change in the resistance, right? Right. IR beam falling on LDR. Okay. First question. When IR beam falls on the LDR, let's read it, is its resistance is equal to 50. When IR beam falls on it, right? Remember that these data actually you have to write it down, so I'm going to write it as well. So when IR beam falls on it, it's 50 ohms. Determine the corresponding value for V1, V2 and Vout. If IR beam falls on it, here it's 50, 50, all are equal, right? Here it's 0. So potential here is 10. So R1, 1:1 ratio, 1:1 ratio. So the potential here, it has to be 1:1 ratio. So it's 5, right? Of course, you can write it down using the ratio is, you can write ratios 1:1 or something like that. Then just 10 divided by 2 is 5 or something like that. Of course, you can write. Or you can easily write, it's just here it's 5 volt. Right, it's 5 volt here, so V1 equals 5. And here of course it's 5 volt, there's no current flow like that here. Yeah, even if it is, it's this potential and this potential is connected, right? Yeah, here it's 5 as well, so V2, it's 5 here, so it's V2 5 here. And we need to find V out. Actually, student, from the previous question, now these values are equal, R and R are equal. From the previous question, we wrote V out You can see V out equals V2 minus V1, right? So like equal V out equals 0. Easy as that, right? Moving into the next part, right? The second part of the question. Now the burglar comes and he crosses the IR beam, and when IR beam is covered, now they are telling the LDR becomes 10 to the power 6, of course. Now there will be an effect on V2, right? Here, this potential, because now the current flow, okay. So just like the very previous method, what we are going to do, we should do is we have to apply the ratio method. So 50 ohms is to 10 to the power 6. See, now it's a very, 50 ohms is a very high value. 50 ohms is a very small value compared with 10 to the power 6. So 10 to the power 6 is a very high value. So what actually happens is the potential at this point should be equal to 10 volts, right? That, of course, you can write 50 is a very small value compared to 10 to the power 6. So the potential at this point is 10 volts. So V2 will be 10 volts, right? You have to write it. Then, of course, very same method, just like the previous method, 1:1 ratio, V1 is equal to 5 volt, right? So by using V out equation, V2 is 10 volt and V1 is 5 volt. So difference is 5 volt. V out equals 5 volt from the very same method. Alright, students, now we are the last part of the question, and D, you have a flip-flop here, right? I hope you are familiar with flip-flops. You have done flip-flop questions and all that. So let's get into the question, right? Before getting into the question, actually, I want to tell you, students, that flip-flops are the new norm, like it's given in a couple of previous years, actually. So you should know. It's after gates, actually, you must have studied these type of questions. And actually, flip-flop is the only device, actually, in our syllabus for now, is the device that can store certain level of memory, 1 bit of memory. So remember that, right? And you have to have a sound understanding about the truth table of flip-flop. So what basically happens if set and reset 0, and what basically happens if set is 1, and then what basically happens if reset is 1. Likewise, you should have the knowledge, right? Let's read the question for sure. Now the output V out of the op amp is connected to the S, right? Input SR flip-flop as shown in the figure. The R input is grounded via two-way switch. So this switch can either go to this 0 potential, or it can go to +5 potential, two-way switch. The alarm should sound when Q equals 1, obviously. Write down the input logic levels S and R for the following statements. For S and R, for the following situations when the IR beam is incident on the LDR. When IR beam is incident on the LDR, we remember it was same potential, right? Same 5. So V out was 0, right? So S0, right? We need to write down. Actually, you have to have the understanding about the truth table of SR flip-flop. Let's write it down here. I hope you can see it. Set, reset, Q and Q bar, right? Students, if set, reset both are 0, this will, Q and Q bar will show the previous signal. So assume previous signal was 1, so it should be 1 and 0, or it should be 0 and 1. So it will show the previous signal, right? So here, when 0 comes over here, 0 and 0, you can see it's connected to 0 ground, 0 and 0. So the alarm, the flip-flop should show the previous signal. What was the previous signal? There was no alarm ringing, right? So it must be 0 here. So Q will be 0, right? Actually, next one, when IR beam is incident on LDR. So when IR beam incident on LDR, so Q will be 0, right? When the burglar cross the IR beam, actually happens here, there will be potential difference and V out is 5. So it will be taken as 1, logic level 1. So S1, R0, Q becomes 1 and Q bar 0. Alarm goes on, Q1, right? Now in the second part, actually it's the easiest one. Now they're asking, actually they would have asked us to write down the truth table first, right? That should be the order of the question, I feel. Anyway, write down the truth table for SR flip-flop. Students, you should know that. Without knowing the flip-flop theory, I don't know whether you can get the first question correct as well, right? If this 1 and 0, so if set is 0, reset 1, Q 0, 1. That of course you can remember. If both are 1, actually we don't give answer here. So here of course you should write down previous signal, right? That of course you have to write down. So this is the truth table for SR flip-flop. Show that, the third part. Show that the alarm will sound when the burglar crosses the IR beam, right? Actually, I accidentally give the answers, right, in the first part of the question. My bad. So I'm not gonna do it again. So what basically happens is when set becomes I'll redo it anyway. So when IR beam is not write down, show that the alarm will sound when the burglar crosses, right? When the burglar crosses, what actually happens is here it becomes 5 volt. So 5 volt will be taken as logic level 1. So when set is 1, reset is 0, what happens? Q becomes 1, alarm goes on. So show that the alarm will sound the burglar crosses you. So this statements you have to write down. So when the burglar crosses here, the V out becomes 5. So the logic levels of S becomes 1. So when set is 1, reset 0, Q becomes 1, alarm goes. That's how you show it, that's how you write it down. Explain why is it desirable to use a flip-flop in this situation, right? Actually students, if you have tried 2014 question, you have seen the answer for this. So that's the importance of doing previous year questions. Students, remember that. When the burglar crosses this point, okay, alarm goes on. Now when the burglar also hears this alarm, right, obviously, so he will move out from this place, obviously. So what basically happens is when he moves out from this place, IR beam, it goes on to LDR, so V out will be 0 again. When the V out is 0, set is also 0 here, 0, 0. What's happening? It will show the previous signal. Previously it was ringing, right? So the thing, the SR flip-flop can store the previous data, so it knows it was ringing, right? So I should keep on going. So alarm will keep on going. So it is desirable, right? That's the purpose of having a burglar alarm system. It has to keep ringing, right, until we switch it off, right? That's the purpose. Explain why it's desirable. You have to write it. Later, the alarm has to be stopped. How could this be achieved? Give reasons for your answer. If you have done previous questions, students, you have seen the answer. So to make Q0, you have to make R 1. So burglar has to move away, first of all. And then what you're going to do is you're going to make R equals to 1. So you have to move this 2-way key to +5. So if you make it 5, if you connect it to 5 like this, R becomes 1, S becomes obviously 0. The burglar has to move, right? 1, 0, Q0. It goes off. Later the alarm has to be stopped. How could you achieve it? Give reasons for your answer, right? Those are the answers I mentioned. That's it, right, last year's students. Now you know, from this question you must have learned that if you have done previous question, doing past papers, doing a NIV question is really, really easy. So at least if you have done 10 past paper questions from electronics, doing the next question is out of question. You can easily do that question for sure, students. So just remember this. I have done few questions from past paper questions. I'm doing this series. So you can check all the other videos that I have done previously and try past paper questions and try to learn something from it. You have to have, if you just have the knowledge from previous questions, you can do the next question, right? If you have completed for last 20 questions from electronics, doing the 21st next question, it won't be that hard, right? So take my advice, Keep practicing, students. Cheers.